The Jurassic period was a golden time for dinosaurs. They flourished for 180 million years after their origins in the late Triassic. By the start of the Jurassic, the dinosaurs had become the dominant terrestrial vertebrates. During this period, huge sauropod herbivores, like the 87-foot 27-meter long Diplodocus and imposing carnivores, such as the 35-foot 11-meter long Allosaurus, came to dominate terrestrial ecosystems. To get a sense of how large these animals were, imagine sprinting as fast as you can. Let's say you can do the 100-meter dash in 14 seconds. To do the Diplodocus dash would take you for seconds. Good thing they weren't carnivores. However, carnivorous dinosaurs also diversified during the Jurassic. Furthermore, the oldest known fossil of a bird is from the Jurassic. Carnivorous dinosaurs, such as T-Rex and birds, are part of the same group called Theropoda. So how did these amazing animals move? And what are the differences between Theropoda, the group that includes birds and T-Rex, and Sauropodomorpha, the group that includes both the Prosauropoda? To answer these questions, let's look at the hips. Specifically, let's focus on the shape of a dinosaur's pelvis. In general, there are two main types of bird and reptile hips. One type has a hole or a large opening in the front of the hip, like this. The other type has a more robust, solid hip with no hole in the front. We call these two hip types the open and closed hip, respectively. The open hip is found in many modern birds and is thought to be the ancestral condition for all birds. This hip structure allows for a greater range of motion, making it more flexible but also more prone to injury. The closed hip is found in most modern reptiles, including crocodiles, turtles, and lizards, as well as in dinosaurs. This hip structure is more robust and provides more support, but it's less flexible than the open hip. Sauropodomorphs have an interesting combination of the open and closed hip. Their advanced or derived hip features a hole in the front, just like birds. But unlike birds, the front and back parts of the hip are still fused together, forming a closed ring. So the sauropodomorph hip is a mixture of more primitive and advanced features. The exact pattern of openings and fusions in the hip bones varies among different groups of dinosaurs. For example, in theropods, the front part of the hip is open, while the back part of the hip is closed, resulting in an overall closed hip. So you could say that sauropodomorphs and theropods each have their own versions of the closed hip. But wait, we said that the ancestral condition for birds is an open hip. And if theropods are the group that includes birds, why do they have a closed hip? If you look at the fossil record, you can see that the ancestors of theropods had a closed hip. Therefore, the evolution of the open hip in birds must have happened after they split from the lineage that led to T-Rex. In other words, birds and T-Rex share a common ancestor with a closed hip. But birds evolved an open hip after they diverged from the tyrannosaurs. Okay, so what does all this information about hips tell us about how dinosaurs moved? Well, remember that the open hip is thought to be more flexible while the closed hip is more robust. Some scientists hypothesize that the more flexible theropods were able to move more quickly and efficiently, allowing them to become the apex predators of their ecosystems or to catch their prey, which often included other dinosaurs. On the other hand, sauropodomorphs were mostly herbivores, so they didn't need to be as quick. Their flexibility would have been less important than their size. Being enormous allowed them to take advantage of the efficient plant-digesting guts that had evolved, enabling them to consume vast quantities of plants. These adaptations may have contributed to their impressive sizes. So, depending on whether a dinosaur was a theropod or a sauropod, its hip bones would have looked quite different. Theropods had a more traditional reptile-like hip, while sauropodomorphs had a unique hip that was a mix of advanced and primitive features. And these different hip structures may have played a role in the different lifestyles of these two major groups of dinosaurs. Now go back and review everything you've learned. See if you can match the characteristics to the appropriate group. You can do it. You're a paleontologist now.